Okay, so you've written some C++ code. You hit run and poof, it just works. But have you ever stopped to think about what actually happens in that split second? I mean, how does a simple text file, just a bunch of words and symbols, transform into a program that your computer can actually understand and run? It kind of feels like magic, right? Well, today we're going to pull back the curtain on that magic. We're going to follow a C++ file on its journey through this amazing digital factory that turns your code into a real working program. Right, so there it is, your beautiful file, ending in .cpp. You've written your masterpiece. But now what? Here's the thing, your computer has no idea what C++ is. It speaks a totally different language, this raw, low-level machine code. Now, some languages, you might know them, like Python, they kind of get translated on the fly, line by line as they're running. C++? Nope, it's different. The entire translation happens up front, before you ever hit run. It's a super precise multi-step process, and that's exactly what we're going to unpack together, piece by piece. So here's our game plan for today. First, we'll get a bird's eye view of the whole journey. Then we'll meet the two main players in this process, the compiler and the linker. After that, we'll talk about these cool things called libraries. Think of them as power-ups for your code. And finally, we'll see how it all comes together to build the final program. All right, let's kick things off with the big picture. And honestly, the best way to think about this whole thing is like a factory assembly line. It's a perfect analogy. Your C++ file, that's the raw material going in one end. And at the other end, a fully functional, ready-to-run program rolls off the line. So let's put on our hard hats and take a tour of this factory station by station. Okay, so here are the four main stations on our assembly line, just at a high level. First, you write the code. That part's on you. But then, the automated factory kicks in. Your code gets compiled, then it gets linked, and finally, it's ready to execute. Now, we're really going to zoom in and focus on those two middle steps, compile and link, because that's where all the invisible behind-the-scenes work happens. First stop on the line, the compiler. You can think of this thing as a super, super strict translator. I mean, it's a real stickler for the rules. It's not just a translator, it's also the toughest grammar expert you've ever met. And its job is very, very specific. So, what is a compiler really? Well, at its core, it's just a special program that acts as a translator. It takes the source code that we write, the stuff that's designed for humans to read and understand, and it converts it all into the low-level machine instructions that a computer's brain, its processor, can actually understand and execute. And this compiler has two main jobs, and it always does them in this order. Job number one, it's a gatekeeper. It reads through every single line of your code and checks that you followed all the rules of C++. We're talking every bracket, every semicolon. If it finds even one tiny mistake, it just stops. Game over. It throws an error and goes no further. But if your code gets the green light, if it's grammatically perfect, then it moves on to job number two, translating all that valid code into machine language. And here's what that looks like in practice. Your mycode.cpp file goes in as the input, and what comes out is something called an object file, usually with a .obj extension. Now, this object file has all the translated machine code, but, and this is super important, it's only the code from that one specific file. It's not a runnable program yet. Think of it like a single perfectly cut puzzle piece. If your project has, say, 3 different .cpp files, you're going to end up with 3 separate object files, 3 puzzle pieces. Okay, so the compiler's done its job. We've got this pile of individual puzzle pieces, our object files. Now what? Well, it's time for the next station on the assembly line, and for our second key worker to take the stage, the linker. This is our factory's master assembler. And just like its name suggests, the linker's whole job is to link everything together. It's the one that assembles the puzzle. It takes all those separate object files we just made and skillfully connects all the dots, combining them into one single cohesive program that you can finally run. So the linker basically has 3 big jobs. First, it gathers up all the object files you've got. Simple enough. But then comes the really clever part. It resolves what we call cross-file dependencies. You know, if you have a function in one file that needs to use a function from a different file, the linker is the one that wires them up and makes that connection. And if it can't find something it's looking for, bam, you get a linker error. Finally, it also grabs any pre-written code from libraries that your program relies on. And this is what that final assembly looks like. You've got your object files, plus any code from libraries, all going into the linker. It does its thing, stitches them all together, and out pops the final product, a single runnable program file, like a .exe on Windows. Now, I've said the word libraries a few times, and they are absolutely crucial to modern programming. So what are they? Honestly, the best way to think of them is like pre-packaged toolkits, or maybe even power-ups for your code. They give your program incredible abilities without you having to reinvent the wheel and write every single line from scratch. And you're going to run into two main kinds of libraries. First, you have the standard library. This basically comes in the box with C++. It provides all the essential, fundamental tools, like being able to print text to the screen using IOStream. It's so important that the linker knows to pull it in automatically. Then you have third-party libraries. These are optional add-ons you can grab for more specialized tasks. You want to play sound, or maybe render complex 3D graphics? You don't build that from scratch. You find a library that does it and link it into your project. So we've met the compiler, the linker, and we know what libraries are. This entire operation, this whole factory process, actually has a name. Let's put a label on it and see what happens after the program is made. Yup, this whole factory assembly line we've been touring, the entire process of compiling all your files and then linking them together into a final runnable program, is just called building. That's it. And the finished product, that final .exe file, we often just call that the build. But of course, getting a successful build is really just the start, isn't it? Because after you build it, you have to test it to see if it actually works the way you want it to. And when it inevitably doesn't, you have to do some debugging to find and fix the bugs. Now, this whole cycle, writing, building, testing, debugging, you almost never do this with a bunch of separate tools anymore. Today, it's all wrapped up in one big application called an IDE, which stands for Integrated Development Environment. It's basically your complete digital workshop. You know, when you step back and really look at the whole thing, this process that's usually completely hidden from us is, well, it's a really elegant factory. It's this beautifully designed system that takes something as abstract as an idea, something you just typed into a text file, and turns it into a concrete reality, a program your computer can actually run. So there you have it. We've walked through the entire process. We've seen the bridge that connects your ideas to actual working software. So now that you know how it's done, the only question left is, what are you going to build with it?